let's start talking about portfolios. This Excel file has the returns that I showed you in the previous video that we calculated in class, so they should come as no surprise to you. We talked about investors should never have one company alone. That company should be in a portfolio. So when we buy a portfolio, and actually we're getting some sort of an average, assuming that we invest the same amount of money in each one of these companies, we are going to get an average return. So let's calculate that. What is the average of these guys? The average of these guys. And now, what is the coefficient of variation or risk divided by return? So boom, we get that our portfolio of these three companies should give us, in any given month, because that's what we're using, 0.461. Let's make it bigger, more decimals, 0.46098 and 5.86, do a couple more, 5.875999, whatever those numbers are. That should be my return and my standard deviation. Good, good. Well, not so good, not so good, not so quick. Portfolios behave differently because we should allow for the possibility that when Oracle goes up, Cisco could actually be going down. So let's take a look at what would happen with the real portfolio. So we're going to replicate how a portfolio behaves. So we're going to go to the Oracle page, which I have it right here. I'm going to get all these returns. I'm going to copy them, all the ones. I'm bringing them to this tab that doesn't have anything except this "Do you believe in magic" sound. Then I'm going to move over here for a little bit, and I'm going to put my Oracle returns here. I'm going to go to paste, but I'm going to paste special, only values. I just have the values here, not the formulas. Now I'm going to go to Cisco, and I'm going to do the same thing. I'm getting all the returns, and I'm putting them right here. Not everything, I'm just pasting the values. I'm going to go to IBM, copy, portfolio, and I'm going to make a mistake on purpose here. I'm going to paste everything. Now, they get 94, 90 something, because now it's looking at, it translated the formula. It brought the formula back. So I'm going to undo this, click undo, and I'm going to go here and I'm going to go paste values. And now I have the returns values. And what I'm going to say is basically the same thing. I'm going to say that this month the average return was rightfully the average of these three returns. But I'm calculating averages per month. So I'm going to copy this, and I'm calculating returns month after month after month, because this is what would actually happen. This month I get minus 3%. The following month I get minus 5. I'm changing this into just a different format to see the same numbers. And now I'm going to come in and calculate the average return of these guys. So what is the average of all these returns, these monthly returns? And what is it? What a big number, 0.4609. I'm going to my summary, 0.4609, but then we have an 8, right? Let's give it more decimal, 77, and we got 77, right? And I can keep going here, and we're getting the exact same result. Well, let's keep going. Let's take a look at the standard deviation. We calculate the standard deviation. We started with the sample one, remember, of these numbers. We press enter, 0.0473. 5 point what? What's wrong here? Did you guys see what just happened? The standard deviation of these guys, of these returns, is lower than the average of the standard deviation of the components. So this is wrong. This does not work. The average return, you get the average return as an investor, but by putting companies together in a portfolio, you get a lower risk. And this, my friends, my students, is the only free lunch we have in finance. Furthermore, take a look at these companies. All of them are from the technology sector. So in reality, what we're looking here is that even when we choose companies that are very similar, just by putting them together, we're able to lower the risk significantly and maintain the same average return. I'm going to explain you how this works. So what happens is that companies have different correlations. So assume that we have companies that have two perfectly negatively correlated stocks. So we have company W, which is this one. When company W goes high, like 35%, company M goes bad, minus 15%. On average, they end up with 15%. When company blue or M goes up, the other one goes down by an equal amount. Up, down, up, down. So basically, all the movements up are cancelled by an equal force, maintaining the average return of the portfolio flat here. So if we look at the standard deviation of the two companies individually, they both look like this: 40% minus 20%, right? Because they both swing widely equally. But if we put the portfolio WM together, there's no risk because the risks cancel each other and we get straight in 15%. What would happen if we get two companies that have perfectly positively correlated stocks? Two stocks that move exactly the same way. Go up and the other one goes up by the same amount. Down by the exact same amount. They just move exactly the same. Well, you probably guessed it. The portfolio M and M is just the same. There's no benefit of this correlation. So a correlation of 1 makes these portfolios non-diversifiable. There's no benefit of the diversification, and a correlation of -1 takes all the risk away. What happens in reality? The correlation is about 0.35, so they're not perfectly correlated. So what happens is when companies like company blue here goes down, the other company goes down, starts going up a little earlier. They kind of go together at some point, but they're not by the same amount. They have different slopes. This means that the portfolio return goes here in the middle of the two. And see how wide these individual companies move and how much less the portfolio line moves. This means that we're going to end up with a lower risk, a lower standard deviation for this portfolio. And this, my students, explains the magic of portfolio diversification.